Hello all. My name is Mahak Gupta, and today we are discussing about network and web security and information security with my friend Ankit Limone. Half part of this presentation is covered by me, and half part of other half part is covered by Ankit. So let's get started. The first topic is describe the goal of transport layer security, short form is TLS, and how they are attained using secret and public key method along with certificates. So the primary goal of transport layer security TLS are to provide confidentiality, integrity and authenticity for data transmitted over a network. TLS achieve this goal through a combination of secret and public key methods along with the use of certificates. First is confidentiality. Transport layer security ensure that the data exchanged between two communicating parties remain confidential and cannot be intercepted or read by unauthorized entities. This is achieved through encryption. Transport layer security uses symmetric encryption algorithms, where a shared secret key is used to encrypt the data, encrypt and decrypt the data. The secret key is negotiated during the transport layer security handshake process, and only the communicating parties have access to it. This ensure that even if someone intercepts an encrypted data, they cannot decipher it without the secret key. And the next is integrity. What is integrity in transport layer security? Transport layer security ensure that the integrity of the data by preventing unauthorized modification of tampering during transmission. This is achieved through the use of message authentication code MAC or cryptographic hash functions. Make or hash functions generate a unique value called a digest for each transmitted message. The receiving party can verify the integrity of the data and calculating the digest and comparing it with the received one. If a digest match, it indicates that the data has not been altered in transmit. The next is authenticity. Transport layer security ensure the authenticity of the communicating parties involved in a connection. It verifies the server and optionally the client in who they claim to be. This is achieved through the use of public key cryptography and digital certificates. The next is attain the using of secret and public key method along with certificates. So some certificates are public key encryption, digital certifications and handshake method. Public key encryption. Transport layer security utilizes public key encryption algorithms such as the RSA or elliptic curve cryptography ECC to securely exchange session keys. During the transport layer security handshake, the client and server exchange public keys. The public key are used to encrypt a shared secret key when securely transmitted between the parties. Only the intended recipient processing the corresponding private key and decrypt the shared secret key. Next is digital certificates. Digital certificates are used to bind the public key to an entity identifier. They are issued by trusted third party organizations called certificate authorities CS. A digital certificate contains the public key information about the certificate owner and the digital signature from the CA. The digital signature ensure the authenticity and integrity of the security. They ensure authenticity and integrity. During the transport layer security handshake, the server presents its digital certificate to the client. The client verifies the authenticity of the certificate by checking the digital signature and ensuring it is issued by a trusted CA. If the certificate is trusted, the client can extract the server's public key from the certificate and use it to encrypt the shared secret key. The process establishes a secure communication channel between the client and server. This is a whole process. And the next question is discuss the reason for using a firewall, various topology and firewall limitations. A firewall is a critical component of network security that acts as a barrier between internal and network and external networks, such as the internet. It helps prevent unauthorized access and process sensitive information by monitoring and controlling incoming and outgoing network traffic based on the predetermined security rules. Firewall is a monitor network traffic. Here are some reasons of using firewall. First is network security, second is access control, third is network segmentation, and fourth one is monitoring and logging. Network security firewall provide a line of defense against various cyber threats such as unauthorized access, malware, viruses, DDoS attacks. By analyzing network traffic and applying security rules, firewall can block suspicious or malicious activities, reducing the risk of unauthorized access and data breaches. Access control firewall allow organization to enforce access control policies by regulating the flow of traffic between different network segments. They can restrict certain types of traffic or specific ports, protocols, or IP addresses, ensuring that only authorized users and application can access the network resources. Unauthorized users can deny it. Network segmentation firewall enable network segmentation, divide a large network into smaller subnetworks or segments. Each segment can have its own security policy, reducing the impact of security breaches by isolating critical system of sensitive data. Firewall help contain and control potential threats. Monitoring and logging. Firewall provide a visibility into network traffic by generating and logging activity. This helps in identifying potential security incidents, analyzing patterns, and auditing network uses. Firewall can also provide a real-time alerts or notifications when suspicious activity or policy violations are detected. The next is various firewall topologies. There are various firewall topologies. First is packet filtering firewall. Second is stateful inspection firewall. Third is application layer level gateway, any proxy firewall. Next one is next generation firewall, NGFW, next generation firewall. Packet filtering firewall, this is the most basic form of firewall. It examines each network packet and filter them based on predefined rules such as a source destination, IP addresses, ports, and protocols. Packet filtering firewall are typically implemented in routers and are efficient for basic security needs. However, they lack advanced capability like content inspections. Next one is state inspection firewall. Full firewall, also known as a dynamic packet filtering firewall. It is also known as a dynamic packet filtering firewall. Maintain information about the state of network connection. They not only examine individual packets but also track the connection state, allowing them to make more intelligent decisions. Stateful inspections firewall are more secure than packet filtering firewall and can prevent certain types of attacks like IP spoofing. Application level gateway, or proxy firewall, this firewall operate at the application level of the OSI model and act as an intermediary between client and server. They validate and proxy all network traffic, applying security policies at the application level. Proxy firewall offer deep inspection capabilities, can enforce specific application protocols, and provide an extra layer of protection. However, they may introduce latency due to the additional processing involved. The next one is the next generation firewall. Next generation firewall is a traditional firewall functionalities with advanced feature like intrusion prevention, deep packet inspection, application awareness, and integrated threat intelligence. They can identify and block sophisticated threats, provide better visibility into application level traffic, and offer more granular control over network traffic. The next is some limitation of firewalls. There are some limitations in the firewall. Limited protection against the insider threats. Firewall primarily focus on securing the network perimeter. They may not be effective in preventing internal attacks or unauthorized access by insider who are already within the network. Inability to protect against encrypted traffic. The firewalls face challenges in inspecting encrypted traffic such as data transmitted over HTTPS. While newer firewall offer SSL TSL decryption capability, it can introduce performance overhead and may not be suitable for high speed networks. Vulnerabilities to advanced threats. Firewall have certain limitations in detecting and mitigating sophisticated attacks. Advanced threats like zero day exploits or polymorphic malware may evade traditional firewall defenses. Additional security measures such as the intrusion detection, prevention systems, IDPS are often required to enhance network security. Complex configuration and management. Firewall can be complex And the next question is diagram and explain the use of virtual private network. A virtual private network is a technology that enables secure and private communication over a public network such as the internet. It establishes a virtual encrypted tunnel between a VPN client and VPN server, ensuring that the data transmitted remains secure and protected from unauthorized access. The diagram this is shown below. First is VPN connection, VPN client, VPN server in different cities like Mumbai, Tokyo, and Seoul, and some VPN public IP address, and they are connected in a local area network LAN of corporate office at Washington, USA. And there is some switches. Okay, explanation. In this diagram we have three main components: the VPN server, VPN client, and the internet. The VPN server is a dedicated server that acts as a gateway for the VPN network. The VPN tunnel is an encrypted channel through the which data between the VPN client and the VPN server encapsulates the original data in a secure wrapper. Next is VPN client. The VPN client is a software or hardware device used by an individual or organizations to connect to the VPN server. The client initiates a connection request to the server, establish the VPN tunnel. Once the tunnel is established, all network traffic from the client is routed through the tunnel to the server. The ensure that the client data is protected and appear as if it is originating from the VPN server's location. The data is transmitted in the home agent to a foreign agent with the help of using tunnel. When a VPN connection is established, the client's data is encrypted and encapsulated within the VPN tunnel. This provides several benefits. First is security. The encrypted tunnel ensures that the data transmission between the client and server is secure and protected. And next is privacy. By routing all network traffic through the VPN tunnel, VPNs hide the client address and online activity from the client internet server service provider ISP and other network observers. Next is access control. VPN allows user to access resources they may be restricted based on their geographic location or network permissions. And anonymity. VPN can provide a certain level of anonymity by making the user's true IP address and replacing it with the VPN server's IP address. This makes it difficult for website or online services to attack and track the user's identity and locations. The next question is describe common denial and of service attack, DDoS attack, including distributed amplified attack, along with countermeasures taken at the computing system, protected protocol design, and backbone provider levels. Denial of service, DDoS attacks are malicious attempt to disrupt the availability of computer system, network, or service, making the inaccessible or to legitimate users. There are various methods for executing DDoS attacks, including the distributed and amplified task. To mitigate the impact of this attack, countermeasure can be implemented at the different levels: computing system, protocol designs, and backbone providers. Common DDoS attack methods. First is flood attack. In this type of attack, the attackers overwhelms the target system with the flood of a traffic, consuming its resources and making it unable to respond to legitimate requested. Flood attack can be classified into different types like SYN attack, UDP attack, and ICMP attack. The attackers send the numerous TCP connection requests in SYN packets to the target, but never complete the connection establishment, executing the target resources. Next is UDP flood. The attackers flood the target with a high volume of users datagram protocol UDP packets, overwhelming its network applications layer. ICMP flood. The attackers send a massive number of internet control message protocol ICMP echo request packet to the target, resulting in the network congestions. Distributed denial of service. Next is DDoS attack. Distributed denial of service. This attack involves multiple compromised system known as a botnet launching a coordinated attack on a target. The attacker gain control to this system, often through a malware infections, and command them to flood the target with traffic simultaneously, making it default to defend against due to the distributed nature of the attack. Next is amplification attack. Amplification attack exploits services that respond with larger respond than the initial request, enabling the attackers to generate a high volume attack traffic with minimal resources. For example, DNS amplification, the attacker send a small DNS query to a misconfigured DNS server, which respond with a much larger DNS responses, overwhelming the target. NTP amplification, the attacker send a small query of vulnerable network time protocol server, which replies with a larger response, consuming other targets and bandwidth. The countermeasures, computing system levels, protocol design level, and backbone provider level. So computing system level, rate limited instruction defection prevention system, and load balancing. Protocol design level, sync cookies, IP spoofing, and traffic filtering. And backbone provider level is traffic scrubbing and backholding. The next is define packet filtering. A packet filtering firewall is a network security features that control the flow of incoming and outgoing network data. The firewall examine each packet, which comprise user data and control information, and test them according to a set of pre-stabilized users. If a packet complete the test successfully, the firewall allow it to pass through its destination. It reject those that don't pass the test. Firewall test packets by examining sets of rules, protocols, ports, and destination addresses. In system networking, packets are formatted units of data carried on packet switching network. This network can be fault tolerant because they deassemble messages into smaller pieces or packets and send them separately across the network. When package pass the firewall and arrive at their destination, they are recorded to display their information correctly. Done correctly, packet switching optimize network channel capacity, minimize transmission latency, and increase the effectiveness of communication. Packet contain two important components like header and payloads. Header, packet header direct the data or to its desired destination. They contain portion of internet protocol like IP addressing and any other data required to get the packets where they are meant to go. Next is payload. The payload is the user data within the packet. This is the information that's trying to get to its destination. There are four primary types of packet filtering: static packet filtering firewall, dynamic packet filtering firewall, stateless packet filtering firewall, and stateful packet filtering firewall. And also the benefits of the packet filtering firewall is efficiency, transparency, affordability, and accessibility. And some drawbacks of packet filtering firewall is the reduced security, inflexibility, inconsistent applicability.
Discuss the ramifications of the HTTP and HTTPS web platform design being stateless. The stateless nature of the HTTP HTTPS web platform design has significant ramifications on how web applications handle and manage users, sessions, and data. Here are some key ramifications. First, session management. In a stateless environment, the server does not retain any information about previous interactions with the client. Each request from the client is treated independently. As a result, managing user sessions become more challenging. Web applications need to include session identifiers in each request to associate with it the correct user session. The session management mechanism, such as session tokens or session IDs, are used to maintain state between requests. Second, data persistence. With no inherent state, web application cannot rely on the server to store and maintain data between requests. If persistence is required, data must be stored externally, such as in databases, files, or caching system. Each request must include sufficient information to identify and retrieve the relevant data. Third, scalability and load balancing. The stateless nature of HTTP allows web applications to be easily scaled horizontally by distributing incoming requests across multiple servers. Load balancers can distribute requests evenly, as there is no dependency on maintaining session specific information on a particular server. This enables sufficient efficient utilization of resources and high availability. Fourth is security considerations. Stateless design simplifies security considerations in some aspects. For example, the absence of site server sessions state reduce the risk of session hijacking or session related vulnerabilities. Additionally, stateless design facilitates the implementation of security measures like load balancing, load balancers, and reverse proxies. Performance. Stateless design generally leads to improved performance. Without the need to manage and synchronize state across requests, servers can process incoming requests quickly and efficiently. Additionally, statelessness enables the use of caching mechanism as responses can be cached and served to multiple clients. The next question is describe the basic structure of URLs, HTTP request, and HTTP digest authentication as they relate to security. Uniform Resource Locator URLs. URLs are used to identify and locate resource on the web. They consist of several components such as scheme, subhost, port, path, query parameters, second level domain, top level domain, subdirectories. First is scheme. The scheme indicates the protocol to be used for communication such as HTTP, HTTPS. Host. The host will specify the domain name of or IP address of the server where the resource is located. Third is port. The port number represents the network port on the server that is listening for requests. Default ports are used if not explicitly specified. Example 80 for HTTP and 443 for HTTPS. Path. The path denotes the specific location or file on the server that represent the resource. Query parameters. Query parameters provide additional information or data to be passed to the server as the part of the request. HTTP request. HTTP Hypertext Transfer Protocol. Requests are used to communicate between clients and servers. They consist of the following components: request method, headers, and request body. Request methods. The method indicates the type of action the client wants to perform, such as get, post, put, delete, etc. Headers provide additional information about the request, such as the user agent, accepted content types, and authentication credentials. Request bodies. For method like post put, the request body carries data or information to be sent to the server. HTTP digest authentication. HTTP digest authentication is a method used to authenticate clients to servers over HTTP. It provides a way to securely transmit credentials without sending them in plain text. The authentication process involves the following steps. First, client request. The client sends an initial request to the server indicating the desire to access a protected resource. Server challenge. The server responds with a challenge which includes a nonce, a unique value, and other parameters. Client response. The client computer computes a hash of the user credentials along with the nonce and other information and sends it to the server as the response. Server verification. The server verifies the client response by computing the hash again using the stored user credentials and compare it with the received response. Next question is explain the use of HTTP cookies, including session cookies, expirations, and re-authentication of key operations. HTTP cookies are small pieces of data that stores on the client side, typically within a web browser, and sent along with subsequent requests to the website. They play a crucial role in maintaining session state, personalizing user experience, and enabling various features on websites. Here's an explanation of the use of HTTP cookies, including session cookies, expiration, and re-authentication for key operations. First, session cookies. Session cookies, as also known as temporary cookies or in-memory cookies, are created when a user visits a website and are stored in the browser memory until the user closes the browser. They are typically used to maintain session state between multiple requests and allow the server to identify the user and associate subsequent requests with their sessions. Sessions cookies are essential for enabling features like authentication, shopping carts, and personalized experience. Expiration. Cookies can have an expiration time associated with them. If an expiration time is set, the cookie will persist on the client side until that time is reached. Even if the user closes the browser, persistent cookies can be used for purpose such as remembering user preferences, auto logins, or tracking user behavior over an extended period. When a cookie expires, it is automatically deleted by the browser. Reauthentication for key operations. HTTP cookies, particularly session cookies, are used for reauthentication during key operations or subsequent requests that require user authentication. After the user initially logs in and establishes a session, the server sets a session cookie in the user's browser. This session cookie is then sent back to the server with each subsequent request, allowing the server to validate the session and authenticate the user without requiring them to re-enter their credentials for every request. This reauthentication mechanism simplifies the user experience and avoids the need of repeated logins. Security considerations. While HTTP cookies offer convenience and session management capabilities, they also pose security considerations. Some key security credentials related to cookies include cookie security flags, cookie tampering, secure storage. Cookie security flags. Setting appropriate security flags on cookies, such as the secure flag for HTTPS only transmission and the HTTP only flag to prevent client-side scripting access, helps protect against various attacks. Cookie tampering. Cookies can be tampered with by malicious actors. Implementing measures like encrypting or signing the contents of the cookies helps ensuring their integrity and prevent unauthorized modifications. So, secure storage. Storing sensitive information within cookies should be avoided. Instead, cookies can reference sessions, identifiers, or other server-side data, stores and maintain session states securely. Next question defines cross-site scripting. Cross-site scripting is a web security vulnerability that allows attackers to inject malicious scripts into web pages viewed by the other user. It occurs when a web application does not properly validate or sanitize using supplied input, allow the execution of arbitrary code in the context of targeted website. The basic idea behind the XSS is that the attacker inject malicious code into a website, which is then served to unsuspecting users. When the user's browser interprets the injected code as a part of the website content, it can lead to various harmful substances, including cookie theft, data theft, deficient phishing attacks, malware distributions. Next question: explain an SQL injection attack and various methods of remediation. SQL injection is a type of web security vulnerability where an attacker can manipulate or inject malicious SQL statements into an application's database query. It occurs when the application does not properly validate and sanitize user supplied input, allowing the attackers to execute unauthorized SQL commands. To remediate SQL injection vulnerabilities, several methods can be employed. Input validation and sanitization. Web applications should validate and sanitize user input to ensure it addresses to the expected format and structure. This includes using input validation techniques such as whitelisting or regular expression to allow all the valid inputs and rejecting or sanitizing any input that contains suspicious or malicious characters. Parameterized queries and least privileges. Stored procedures. Utilizing stored procedures can provide an additional layer of security by encapsulating SQL statements within stored procedures, and the risk of SQL injection can be mitigated since the input values are treated as data and not part of the SQL command itself. Web application firewalls. WAFs can help detect and block SQL injection attacks by analyzing incoming requests and blocking those that contain suspicious and malicious SQL patterns. WAFs can provide an additional layers of defense while other remediations measures are implemented. Regular security audits. Regularly conducting security audits and penetration testing can help identifying and remediate SQL injection vulnerabilities. These audits can help identifying weak points in the application's code and database interaction, ensuring that proper security measures are placed. Next is write short note on OWASP and the OWASP top 10 list. OWASP, which stands for Open Web Application Security Project, is a worldwide non-profit organization dedicated to improving the security of web applications and softwares. Uh, OWASP provides valuable resources, tools, and documentations to help individuals and organizations understand and address web application security risk. One of the most well-known contributions of OWASP is the OWASP top 10 list. That OWASP top 10 is a regularly updated document that outlines the 10 most critical web application security risks. It serves as a guide for developers, security professionals, and organizations to prioritize and address common vulnerabilities that can be exploited by attackers. The OWASP top 10 list is based on the real world data, including vulnerability prevalence, industry trends, and community input. It aims to provide a concise and accessible overview of the most significant security risks facing web applications. By understanding and addressing the issues highlighted in the OWASP top 10, developers can build more secure softwares and reduce the likelihood of successful attackers. Thank you so much for listening to me. That's it.